We are joined by Professor Isaac Kohane, who is Marion Nelson Professor and Chair at the Department of Biomedical Informatics at Harvard Medical School. He develops and applies computational techniques to address disease at multiple scales, from whole healthcare systems as living laboratories to the genomics of neurodevelopment, with a focus on autism. We also have Professor Manuela Veloso, who is head of JP Morgan Chase AI Research and Herbert Simon University Professor at Carnegie Mellon University. At JP Morgan Chase, she leads an AI research group focusing on AI in finance in the areas of financial crime, data sharing, multi-agent market systems, responsible AI, and process automation. We also have Professor Cynthia Rudin, who is a professor of computer science, electrical and computer engineering at Duke University. And there she also directs the Interpretable Machine Learning Lab, and her research focuses on machine learning tools that help humans make better decisions. And finally, we also have Alexander Madry, who leads the MIT Center for Deployable Machine Learning, as well as faculty co-lead for the MIT AI Policy Forum. His research is around algorithms, continuous optimization, and understanding machine learning from a robustness and deployability perspective. So an incredible wealth of talent in front of us here, lots of experts across a range of different fields. What I thought I would do is just start off, if I may, by giving us a bit of a grounding about the most significant breakthroughs in your various fields. So maybe, Isaac, if we could start with you, could you tell us what you think have been the biggest differences that have happened really in the last 5 years across healthcare?
Well, I would say that the two most significant developments, one was in the area of machine learning, which is well understood at this point, and the other is less well understood, which is the liberation of data, which is the necessary grist or substrate for effective machine learning. With regard to the former, I think none of us are at this point surprised that the use of machine learning to recognize abnormalities in images, whether it be on your skin as a potential skin tumor, or on your eye as a potential eye disease, or in your lungs as pneumonia or a cancer, or in pathology to distinguish far better than pathologists who will agree with one another on average, only around 60% in a community hospital and maybe 80% in an elite academic center. So with regard to image recognition, that performance is essentially something that we can take for granted, even though it's not fully implemented throughout the healthcare system. There, it's just a matter of the business models fully coming to roost throughout the world. But this is going to be a great equalizer across academic centers and community hospitals and across the world. We'll have elite performances for images. However, there continues to be an egregious walling off of patient information across these centers. The UK Biobank has been a singular exception to this, but otherwise, for the billions of humans, only an infinitesimal percentage of their data is shared, even if they wanted it to be shared for research and for machine learning to advance care. And in that respect, the recent model that Apple Health has brought to bear, at least in the United States, where an application programmer interface, an API, provides access to the electronic health record to the patient so that they have on their iPhone access to their data in a machinable way. That is a transformative event. It's happened now. Tens of millions of Americans have access to their record, and now machine learning models can be built on those data.
So moving forwards then, as we go forwards the next 5 years, do you think that that's going to be the most significant change that we can expect to see, that people actually start to own their own data a little bit more as simultaneously you see these machine vision algorithms coming more to the fore? Is that what you expect to be the biggest difference?
Well, just because I like to say something memorable, I'm going to disagree with myself and say that the most important healthcare breakthrough is going to be an application of relatively vanilla machine learning in a health domain that is creating hundreds of thousands of sad families worldwide every year. In the United States alone, there are 10,000 deaths per year from drunk driving. And with all its faults, and here's a free advertisement for you, Elon Musk, with all its faults, a self-driving, or more accurately, a human-in-the-loop autonomous driving vehicle is very, very likely to cut down in the United States tens of thousands of unnecessary deaths and far more horrible injuries, and worldwide, an order of magnitude more such. So if I were actually to point on a single public health intervention due to AI, which is going to have more impact in the next 5 years than anything else that we could possibly do, it's not in the healthcare system, it's in driving. These multi-thousand-pound machines going with kinetic energies in the tens of thousands of joules will no longer be as likely to destroy the families in and outside of them.
It's a pretty bold statement there, Zach.
I am ready to take on whatever. If anybody wants to take a bet on me, I'll be glad to.
Well, let me see. Okay, all right. Let me come into you, Alexander, because I think of everyone here, perhaps you're the best person placed to answer Zach's statement there. First off, do you think that this hope that he has is realistic? And then maybe you can also add to that of what you think the biggest changes have been, and what in your field the biggest changes that we can expect in the near future.
Yeah, okay, so I can tell Hannah you are an experienced kind of panel moderator, because you know exactly who to put after this, after this statement. So I must say, Isaac, that I am not as optimistic. Being a machine learning person, I'm not as optimistic about your portrayal of the impact of ML as you seem to be. First of all, my core area of research is vision, and machine learning based vision, and if you have a computer vision system that is reliable and works, I want to see it, because I have not seen it yet. So I think that's, work in progress, and very much work in progress. And there's many reasons that hopefully will go in this panel into why, I will not be as optimistic about just using vanilla ML to do anything. Just to go back also to the question of the cars, again, actually, I do agree with you that even with technology we have right now, we can reduce, the fatalities on the roads by significant amount. By the way, again, as much as we are all excited by Teslas and other self-driving cars, there's a lot of progress happening on normal cars where you have lane following. Essentially, there are all the systems that actually, if you buy any car right now, it actually has quite a decent piece of machine learning already that kind of is not trying to drive for you, but it's trying to help you drive. And I think that actually has a, positive impact. But, the problem with, by the way, again, I agree that self-driving cars or the technology going towards self-driving cars will have a big impact on people. It's a little bit more tricky in terms of making prediction of, how much impact there will be, because humans seem to have double standards when, we talk about self-driving cars versus humans. So if human kind of does something stupid on the road or makes some bad decision, says, well, it was fast, humans are fallible, that's fine. But if Tesla does such a thing, that might kind of completely destroy, put dampers on any deployment.
That is exactly my point. I did my PhD in computer science back in the 1980s during the second heyday of artificial intelligence. And Seymour Papert back there coined the term, the superhuman human paradox, which is that we expect of computers to do better than the average human. And so that was exactly my point. We know just how bad the average driver is. And the distracted driver looking at their iPhone, it is not a high bar to exceed. And that's my point. It's not a high bar to exceed. And furthermore, two more points. that Tesla specifically is keeping human in the loop, which I think is an essential point that we should not avoid. Second, there are some idiots who don't want to be in the loop, but that they'll be selected out fast enough. Second, is that something that should be adopted widely. In order to be able to drive your Tesla through self-driving, you actually have to prove to the machine that you're a safe driver, and it will not give you access to self-driving until you reach 100% score. I defy you to point to any part of medicine where the surgeon is not allowed to actually do surgery on the patient until they get 100% score. So for all the reasons, the bar is so low, I'm quite confident, and I would be glad to take you on in that bet.
Let me just, before Alexander, let me just pause for a moment, because while I love that we're 4 minutes in and we're already in provocative territory, which makes me extremely happy. But while you were talking there, Isaac, I noticed that Cynthia was clapping, like a little silent clap. So I might just come to you, Cynthia, and then in a moment, Manuel, I saw you put your thumbs up at one point. So let me just get a couple of comments from both of you, and then I'll come back to you, Alexander, if that's okay.
Sorry, so I was clapping there because it bothers me that people are allowed to get into a car and drive it when there could be an easy sensor for whether this person is drunk or otherwise impaired. Just that simple.
Yeah, so no sort of machine vision, no like full automation of driving, just something that's actually looking for human fallibility and human mistakes instead.
Well, I mean, that is more likely to work consistently, I think, than some of our current self-driving. I mean, as much as I would love it to know that self-driving cars are ready and the technology is there, I think it's sort of more wishful thinking at the moment.
There's presumably quite an interesting analogy there, Cynthia, with healthcare and criminal justice, where actually a lot of the problems that are created are human mistakes, where actually you probably could have systems running in the background that highlighted our own biases. That was you, Cynthia.
I completely agree with that. I gave a whole talk about that yesterday, actually. Yeah, so I mean, you know, there's a lot of like typos and things that go into any of these decisions. The big, you know, especially you know, it's especially bad when you have like a high stakes decision, like a decision that determines someone's freedom or whether somebody gets a loan they can buy their house, and you have some typo going into that calculation, and there's nothing you can do about it if the whole system is proprietary. So I spoke about that kind of at length yesterday.
So then in terms of going back to my original question about sort of the big differences over the next 5 years, is that the way that you are generally leaning, Cynthia, that it's more about creating systems that catch human mistakes rather than things that necessarily take over?
Oh, I wouldn't make a general statement about about that, but I, you know, I do think that a lot of these high stakes decisions really do need to be made with a human systems level way of thinking about problems. You know, let the machine learning algorithm does what it does well, which is find patterns in databases, right? And then let the human does what it does well, and take that information, take other information that the human knows about that the computer doesn't, and try to put that all together. But those aren't necessarily the biggest problems that I think the AI world has right now. Those are problems I'm working on. Those are problems I think about a lot. But the problems that I think are the biggest in AI right now are things like the propagation of misinformation, right? That happens because of AI, but I don't think that's a technical problem. I think that's more of a regulation problem. But I do think that is probably the biggest problem that the AI world is facing right now, because it's our stuff that's propagating all that misinformation. It's our stuff that's being weaponized.
I tell you what, let's come back to that point a little bit more in a moment, because I just wanted to come to you, Manuel. Would you go along with what's being said here about, I guess, about machine oversight on human decision making, and what do you think are going to be the biggest challenges as we head forward?
Yeah, thanks a lot for having me in this panel. It's great to be listening to these other panelists and feeling itchy about answering.
You can all jump in, by the way.
And with Cynthia, and agree with Isaac, and of course with Alex too. But I want to tell you one thing that I find that we kind of all miss. I just want to give one example here about this problem of humans and AI. I once was talking with a professor who had done like 30 years of research on autopilots. And she was extremely, this is before this fever of AI kind of thing, but she was extremely, how do you say, disturbed by the fact that in this autopilot mode in which the machine does all of these, when the machine realizes that it cannot handle and it passes it to the human one way or another, there is a big problem with this passing the information to the human, because the human, unfortunately, did not follow all the actual information that was going on and feels completely like out of nowhere is called to solve this problem. And there is, and her research was exactly on this problem. If you pass all the information to the human, then the role of the autopilot is zero, because after all, the human is keeping track of everything. But on the other hand, that transition when the autopilot or when some kind of AI system realizes I can't make it, it's difficult, because then the person doesn't have the context, doesn't have the understanding, doesn't understand the derivative. It's just hard. So I think that for me, after joining JP Morgan recently, after being like 30 years at Carnegie Mellon, developing autonomous robots to play soccer, to move down corridors, to actually reliably going for kilometers and kilometers in the building, interacting with people, not autonomous cars, but my passion is indoor robotics. So this is like, I now realize, and I tell you, this is something that even I am puzzled, how am I going to do this? That somehow the mystery of this AI, and again, coming back to Cynthia's point also, is this humans and AI. It's this little and that's the problem. Because for things that AI can do it by itself, we can check mark, yes, you know, it probably is going to be able to play chess or something by itself, alone, beating, AlphaGo, it doesn't matter. For things that humans do by themselves, yeah, you are going to play golf maybe one day with a robot, but still you can write a great script and be a Shakespeare and whatever, fine. What about the things that we can do together? What about the things that eventually, and also the machine can classify cats and dogs, yeah, fine, they classify, that's okay. But what about this challenge of including both these two machines talking together, the human machine, the AI machine, in a way that also something I realize now, one way or another, these humans have a tremendous amount of knowledge. So for me, what matters here is to focus on these magic, and I think that I don't have answers necessarily, but that it's the research, the big research question is this coexistence problem. And so that's what drives that takes my sleep at night. That's what drives a lot of the research I do, is trying to see how do we bring this knowledge, and we cannot ignore that humans know many things, to the actual capability that the machine has to analyze data and to extract patterns and to. Anyway.
I'm reminded, Manuela, as you were speaking there, of that amazing essay by Liz Ann Bainbridge, of the ironies of automation. If anybody is watching and hasn't read it, it's really a very amazing summary from like the 1980s or something, of precisely the problem you were talking about. Now, Isaac, I'm going to come to you in a second, but I promised I'd go back to Alexander, and I can't possibly break my promise. But I think, Alexander, in many ways, the things that Manuela was saying there speak to what you were first talking about, really, about that collaboration being so difficult.
Yes, so exactly. So yeah, I'm not surprised that, you know, we agree with Manuela here. Is just like, so I agree that, you know, okay, so I first of all agree with Cynthia that simple things can have a big impact, and they will have the big impact. And that's where kind of, if you are looking for next 5 years, that's where most of the impact will be. But the tricky part there will be what Manuela said, is, you know, how to get AI and humans collaborate, because this is the super difficult thing. Like you said, this Tesla model that you say, well, we're not really self-driving, we are kind of autopilot, but you need to be ready to take over whenever something happens. And if something happens, it's your fault anyway. That's just like completely untenable. Like what happens in, you know, if you look at one-on-one in California, people just drive Tesla and read newspaper. There's no way for them to react to anything, because this is kind of untenable interface model. And again, exactly, the problem is that when kind of they have to share some task as opposed to delegating something versus taking over something. So I think that's a very difficult thing. And again, I would love to go more into it if we choose to, because I think this is where the future of research in the context of reliable ML has to be.
Well, I I sort of wonder actually about that example of the people reading newspapers. I hope that doesn't really happen. I hope that's sort of just like.
Oh no, this is really happens. So you can
really.
Yes.
Yeah,
Yes.
it
Okay.
happens.
So
Yes.
then, but then isn't that a design flaw of the Tesla that can be able to happen for something that's so clearly unsafe?
Well, but that's the point, is that like humans act the way they act. So either you tell me I have an autopilot and then I can rely on it, or I have to drive all the time. It's very hard for humans to be in this mode of like kind of not driving, but driving. So this goes back to exactly what Manuela said about this autopilot example, way past any AI was there. Like you need to have a clear delineation. What is the role of AI and what is the human role? And they really, again, there's, by the way, another facet of the problem, and this is particularly in the healthcare domain. My colleague Marzia Gazemi works on this a lot, about like how difficult for people it is to get input from AI and meaningfully incorporate it into the decision process. So that's another thing. But anyway, like just we need to recognize that humans are interesting beasts, and the way they kind of try to sometimes anthropomorphize AI or sometimes view it as a reliable tool, like we have these abstractions and we try map AI to it, and we need to recognize that and not just try to say, oh no, that's neither of this, and it's your fault if you cannot really interface with it properly. So anyway, I have many other points, but I guess you like to keep it very lively, so I will let
Well,
you
I think Isaac's going to kill me unless I let him come in now.
Yeah.
No. This is a great discussion. I think we're actually discussing really, I think, the heart of the matter, and I think we're actually converging on there's actually a broad convergence. I have some nitpicking points that I'd love to crush Alexander with, but I'll see if I can behave myself or not. Well, for instance, yesterday I was giving a talk at your conference, and I actually was making the point that the vaunted predictive ability that Google, for example, has demonstrated on using electronic health records to predict various outcomes was in fact an illusion, because what in fact these Google machine learning programs were doing, these time series predictors, were in fact keying off of physician behavior. In other words, it was just as important in the predictive power of these programs to see what the doctor had ordered, just like a very attentive medical student can figure out what's going on with the patient by following just within a few minutes what the doctor saw, and just by using that can actually make an accurate diagnosis of the patient without actually understanding the patient, just by keying off of what the expert doctor did. And my point that I made was that there was going to be a very productive alignment between the natural general intelligence of humans who recognize commonsensical situations and the very specialized AI machine learning programs that can recognize patterns. And that entente is going to be much more important, I maintained, than interpretability for safe AI. I will bite my tongue. Actually, I won't bite my tongue. Here's what I will say. I've worked in academic AI for 30 years, and I think that very few people have the experience of a real consumer application like Tesla being used by millions of people with hundreds of millions of miles more than any other machine learning laboratory ever existed in the world. And with a user interface that, by the way, will continuously remind you that you should be on the wheel. If you don't actually do something with the wheel, now I admit that someone with a newspaper might actually just jiggle the wheel to say, oh yes, I'm paying attention. But that's a work in progress. And again, the bar is so low on driving that I will take a bet against Alexander about the net deaths on inferior, slight AI and middle AI compared to Tesla in the next 5 years. Now, of course, on the merits, I fully agree with Alexander and Cynthia and Manuela. there's going to be a thoughtful and principled entente between natural intelligence and artificial intelligence, and how it's done and done well is going to matter. But I'm telling you, at the hairy engineering level, at the consumer level, it's happening today with data sets that very few people in academia have ever seen.
I do wonder, just to pick up on something that Alexander said earlier about the idea of double standards between humans and machines, because while if you're looking at sort of net deaths overall, I think that, I imagine there's certainly an argument in favor of what you're saying. But I do also wonder, there's a question that came in from Richard Pinch here. And incidentally, everybody, please do write questions in the Q&A box, and I'll try and feed them in as we go along. To simplify it, essentially, Richard asks, how can we feel confident in defending decisions made by such an AI system? I guess the point I'm trying to make here perhaps is that while deaths with a human at the wheel are defended in court as it being sort of instinctive or, snap decision made in the moment, a death that's created by an AI is one that presumably has a lot more, intellectual rigor behind it. And when I might come to you on this question, do you have thoughts about that difference between how much blame should be assigned to one over the other?
Yeah, it's a good question. And in fact, I think that people are much more lenient with humans than with AI. But I do think that one way it's the right way to be, because somehow the AI is something that we can manufacture. So the AI doesn't exist as a product of some DNA. It's actually something that we can hopefully, through the data we train, through the feedback we give, to the continuous learning, this machine can evolve to be something probably, hopefully, better in terms of values, in terms of accuracy, in terms of breadth, in terms of big heart, than eventually the individual humans. Now, I do want to say one thing, that for my machine learning friends here and for myself who do machine learning, that somehow I think that the problem of machine learning and the way we look at this is that we are looking at machine learning a lot as the one-shot deal. I mean, is it the cat? Is it the dog? Is it the tumor? Is it not the tumor? Is it like a car? Is it not a car? So we are in that business of kind of like taking a snapshot of the world and just classify it. And we think that's what machine learning, and it is very good at doing. However, and it will help to solve the sensing problem. Are you drunk? Are you not drunk? I mean, it is kind of thing. However, a lot of the things that we need help for from AI involved history, involved the fact that, in fact, this person made a decision yesterday about this, and it needs to be consistent. And it's a lot about behavior and human behavior, and a lot of handling situations that are not just of data nature. I mean, in the sense, it's not looking at the stars, it's not looking at cats, it's not looking at dogs, it's decisions, loan, no loan, decisions like credit, no credit, decisions that this person or whatever. So these are complicated decisions, much more than decisions about our physical world, or about like objects in an environment, or about like all the things I've done with robotics, that actually is these, am I in front of the elevator or not? Okay, there is no opinion here. This is like a factual knowledge. So I do think that another challenge, in addition to the humans and AI challenge, is this continuous learning. So the continuous learning, so systems, AI systems that don't deliver and that are evaluated not by the answer they deliver now, which they need to deliver the right thing. Do I hit this wall or not? I mean, so there is people, so AI systems will have to make decisions. However, they will have the blame that you were just saying for the decision they make, for sure, but also the blame should be based on, did they improve from last time? Or are they going to next time do the same error? So I'm not as worried about the biased decisions that AI makes today, but I'm worried about that it doesn't get better. If it continues to do the same biased decisions tomorrow and a month from now and next year, and we keep like, oh my God, this machine is just crazy. It's all messed up. We cannot find the right data to give to it. We cannot find. That's the problem. So I think that in the future, in this credit blame assignment, with humans, we kind of like, okay, made the human, when we have a hope that the human will eventually improve or learn from the mistake. We have this very beautiful term for humans. The best thing of mistakes is that you learn from them, right? So this is like how we think about mistakes. Well, AI needs to do the same thing. AI needs to be something in which you give feedback and the machine keeps improving. So we should evaluate AI on the derivative of course, for decisions it makes now, but the problem is that what if this thing never gets better? We give more data, we give more, and the thing is still making less in percentage of biased mistakes. It's still not being able to explain itself. It's still not being able to do anything. So I'm telling, my heart is on developing AI systems that we have some compassion for one way or another, but we are demanding in terms that the algorithm becomes better over time. We are demanding on the ability to ask, why did you make this decision? We are demanding on actually giving input and requiring this thing to speak up to you. We are not going to be able in the future to interact with an intelligent creature, which is not a dog, not a cat, pretends to be a human, who is not capable of responding to our questions, to try. So this is the big mystery. It's like I love deep learning. I love all the work on vision. I use it somewhere, but somehow we have to understand that the challenge is the whole AI thing, is to create a creature, artificial creatures that we can interact with and can support you, can assist you, can do tasks that are very complex for humans in scale and in complexity, and can learn over time. So just so we know, this continuous learning is something also that I really find that it's a very big area of research for us all.
I really like I mean, there's a lot of things that you said there, Manuela, that were very interesting, but I really like the idea of evaluating something on the derivative. And there's a sort of kinder way to evaluate something. And Cynthia, you wanted to come in here.
Yeah, I mean, so these questions of how do we make sure that AI improves, how do we assign blame, all of that kind of stuff is all tied into interpretability. If you actually understand what the system is doing, you can figure out what actually happened. Why did that car run over that person? And figure out like what exactly was the computer vision system seeing, and how can we actually assign blame for what happened here? Did someone come up in front of it with a sign that was designed to fool it? Was it just that, that actually did look like a thing, and so that's why it got confused? Without interpretability, it's really hard to sort of figure all of that stuff out and improve the system for the future, because interpretability is, in my experience, the key to being able to troubleshoot these models.
So one thing, actually, I guess so far, the type of decisions that we've been talking about, Manuela, is sort of the point that you were making, that they're all sort of one-shot decisions, right? Like either something is right or something is wrong. And actually, I just want to come back to what you were saying earlier, Cynthia, about the propagation of misinformation, as though actually there's a question here about scale, that once you can automate something, that we enter into a new paradigm where things that weren't possible before suddenly become so. Could you just tell us a little bit more? Actually, there's a question by Thomas Gaskin here too, that really speaks to all of this. Tell us a little bit more about what you mean about one of your big concerns for the future being the propagation of misinformation. And Thomas here wants to know whether whether the increased speed of misinformation is really driven by automation and by AI, or whether it's actually driven by human behavior.
It's driven by both. I mean, you've got humans who are weaponizing these AI algorithms. I don't even know how AI-ish they are. I mean, they're pretty simple, I guess, but these are algorithms designed to keep people on the platform. They're designed to keep people interested, and those algorithms are being used. They're being weaponized by people to propagate misinformation. I mean, do you read the newspaper? Like, it's everywhere in the newspaper, and I think it's causing so many problems for our society. The fact that this pandemic is not over, the fact that there are lawsuits by the Rohingya people against Facebook for genocide. Like, all of these things are because of the propagation of misinformation. It's because there are people who are actively trying to propagate falsehoods. It's preventing us from doing anything in politics, right? Why the government is so gridlocked on doing anything that's going to help people. I don't know, but I think that is a problem that I can't really solve, right? That's a problem that regulators need to step in on.
Well, let me ask you about that idea of regulation then. Do you have a sense of some kind of a way forward? What's your view on regulation going forwards?
I'm not sure. I mean, I'm not a politician. I don't really do that kind of thing, but I think there are a number of different solutions that people have proposed that sounded reasonable to me. One is to use our current monopolistic practice laws to break up monopolies. I think that might help. Another is to make sure, or is to regulate these big companies that essentially publish all this misinformation and call them actual publishers so that they're responsible for the things that actually get published. That's another good idea. A third is to change some of these companies into utilities so that they're heavily regulated, right? I'm not sure what the right solution is, but I think all of those options could be on the table.
Alexander, I want to come to you, if I may. Lots of different things that have come up there, things about the spreading of misinformation, the automation of misinformation, as it were, also about evaluating these algorithms, not just on a one-shot basis, but as they continuously learn over time. Your thoughts on the different things that we've been discussing?
Yeah, so this is my problem. I'm sitting here and you are just going through all my favorite topics. And I just like, now I'm afraid what I should spend my kind of allocation of time on. So let me just do very quick whirlwind tour just to get back to the point. So to build on Manuela's point, I think one thing that I think at least the academic, actually it's exactly something between different between academia and industry, is that in academia, we have this view of machine learning being a one-shot thing, also in one more way, in which you just train your model. Maybe you do some verification on it, whatever, you deploy it, you are done. That's completely not how any real system will work. In particular, Teslas, they're constantly being updated. They stream video back to the, to Tesla. They look what went wrong. They have probably some heuristics of flagging what data is useful to retrain your model on. Like this is always from the beginning in operation, that is a continuous deployment. So that's something that like, I think the academic community kind of still is not even acknowledging and not really like, focusing on. So that's just one thing to flag. The other thing to flag is that I think with Isaac, like, I think the bet now is a bit like, I think we're making a different statement. If you ask me if Tesla is a great invention and great technology progress, completely agree. Will it reduce and will it make roads safer? For sure. I'm just more about the kind of self-driving cars on the road narrative, which that's where I am skeptical. So moving forward, one thing, by the way, that you just mentioned at the very beginning, and I think it's very important to just highlight, is about the importance of availability of data. I think that's a big problem in healthcare, but also in vision. If you are not a Facebook, if you are not a Google, actually, as a researcher, that's a big problem. By the way, it's not only about availability of data, it's also about annotation of data, in particular in healthcare. It's just, yes, I can have all these patient records, but if I don't know if it was, I don't know, one nurse versus the other nurse attending that day, and they have a bit different way of like, kind of applying different treatments or making measurements, that all matters for machine learning algorithms, and we might not have this information. Again, moving on, now we get to the social media, which, by the way, I am a colleague on the MIT AI Policy Forum. So that's exactly like what we spend a lot of time talking about. And essentially, in particular, like I have, economist colleagues here who kind of, educate me about naivety of my initial thinking. So I would say, again, this would be the whole panel. So I would just go very short. It's just like, I think this is what makes this thing very difficult. It's actually an area that you cannot delegate neither to politicians, nor to academics, nor to industry. The problem is that this is kind of in this very kind of uncomfortable interface that we don't know how to really map, because yes, we will need regulation, but politicians have no idea what is the right regulations. Like in particular, when they talk about simple solutions, like, oh, it's a monopoly, break it up, that will not help. Imagine now you break up Facebook into 5 Facebooks. What will happen? Well, essentially, they will start competing against each other. They will even have more incentive to be viral, like, and go for it, because now they fight for survival. So you need to change the incentives of the whole business model there, which again, that's clearly a role of regulation, but now you need to be a bit more nuanced. How do you do that? And now the technical question comes in, is exactly like, what other viable business model could be there? And what is technically feasible versus what is not technically feasible? And the other thing is about, saying that there are publishers. Well, if there are publishers, then, essentially you need to shut down Facebook. There is no way for them to be responsible for everything that people kind of publish on there. And maybe that's a good outcome. I would not, I would be totally comfortable with this. But, there is some positive value that, these social media bring in. So again, I'm just saying this is like a wonderful discussion. I'm happy to have a next hour talk about this, but, I guess it's up to Hannah if that's where you want to go.
Oh God, the power! My goodness. I'll come back to you in a second, Cynthia. I just want to ask you, Alexander, about the point that Cynthia made about making them utilities. What's your view on that?
Well, but that's great. Actually, I think that's a very important point, that like they really became utilities. Yes, like when Facebook went down, there were businesses who couldn't do business because they were completely shut down from their platform. So this is like, I think that's a very important, but I would view it only as a first step, saying, look, there are no longer optional services that you might use or might not use. These are utilities. Now, what does it mean? Right? In context of internet kind of connection, we start to figure out there is something about monopolistic practices, something about making sure that, you don't only connect the communities that are rich and easy to connect to. Like there's a lot of that. So we definitely, like, to me, this is just absolutely agree. These are utilities. Now the question is, what does it mean? Like kind of what kind of regulation should come with that? And that's, I think, where the difficulties start, which we very much should be grappling with right now.
Cindy, you wanted to come back in.
Yeah, I was just going to say, like, so I appreciated Alexander shooting down all of the things that I read on the internet as possible solutions, but you have proposed no good solutions.
Yes.
I hate that when people do that, when you're like, oh yeah, there's like a lot of possibilities, and then they just go, no, that won't work. No, that won't work. No, that won't work.
Yeah.
You've got to present something that's actually going to work.
Yes, and that's a nuanced work, and I totally agree that it's difficult. Like, again, by the way, this shooting down is what my economist friends did to me when I commented. So I'm just the messenger here, so don't shoot the messenger. I'm not becoming them, I'm learning from them. But the point is that, yes, the question is exactly like, what do we propose forward? And I'm thinking about this hard. I cannot say I have a solution. I'm just saying, just going for simple solutions might actually do even more damage than not, because there is a momentum right now in politics to have regulations around social media. But once they kind of do it, they say, okay, we are doing this, we did that, just leave us alone. Now we fix the problem. And if we don't get it right, that will be actually a huge, a missed opportunity. So that's all, again, that's all I wanted to say. I'm not saying I know the solution, and I think we should all think about the solution. And I don't think politicians alone will come up with the solution.
So let me bring.
I was going to go to Isaac actually. I promise I'll come to you next. But I think the point that you're making here, both of you, this is something that is really fundamentally important. It goes well beyond social media, because I mean, if you think about, for example, Google stepping into healthcare, this is the things on climate opportunities and so on. I think that this is answering these questions goes beyond just the control of your Twitter feed. But Isaac, do you have the solution for us, Isaac?
I don't know if I have a general purpose solution, but I do have, again, in the spirit of my original comments, a solution for healthcare that I think advances the agenda, which is right now we have several parties controlling information of our information, our healthcare information, with a variety of different levels of benevolence or not. And I think that by putting patients in control of their healthcare information and educating them to be better patients so they understand the information, so that they understand where the healthcare system is broken and where they could use a little bit of automated support to enable them to understand how they can serve as advocates for their loved ones, to allow there to be created nonprofits that with varying reputations that will advocate on their part, that will use those data that have been liberated on their behalf. I think that's where we can have a considerably advanced, both ethical and socially constructive system, far in advance of where we are today. And anybody who's had the misfortune to have a loved one or to be themselves in the healthcare system know how far short we fall on the supposed transportability of data across healthcare venues, of intelligent interpretation and authoritative interpretation and state-of-the-art interpretation of your genomics in your tumor, and how it differs from a leading institution to a backwater institution. There are such huge disparities and even in the best intentions, such craven mistakes and miscommunication that I think the liberation of data and creating of a intellectual and true marketplace where the patients are in control is probably the single most important thing we could do to advance healthcare. I don't know if that's a model for the rest of our problems that ail us, but I'm very certain that is true for healthcare.
Lots of nodding across the board there. So that's, I guess, healthcare sources. Manuela, I know you wanted to come in too.
Yeah, so I wanted to go back a little bit just to also the regulator issue that Cynthia raised and Alex too and so forth. So so I've been talking a lot. I mean, I've been knowing a lot about regulators, and I think there is something that I also think that we need to understand. No matter what, these regulators also don't know how to do it right. It's not that they are the how do you say, like these wizards, or that they are like these oracles that magically have the answers. They just don't. They actually look at us in the AI community to come up ourselves with what should be regulated. So we are actors in this together. We are not spectators. So what I'm trying to say is that this problem of regulation is complex because, again, so we solved it for several other things. For example, think about the food industry. If you actually have a new milk that your cows produced, you are not allowed to just put the milk in the shelves of whatever Whole Foods without going through some process of acceptance that the thing is safe and can be sold to the rest of the world. So the drug industry, the car industry, the food industry, they all solve this problem of regulating before releasing to the world. And someone needs to check markets safe. Someone needs to check markets. But it was a process. I mean, this didn't exist a century ago. So what I'm trying to say, AI is a new discipline that we are all handling, but I do believe that it's part of our mission, it's part of our research, it's part of our business to actually help these regulators come up with what should be tested, what should be regulated, what should be like the rules of the game. I do think that there is something different in AI than nuclear power or bioengineering or something, because somehow this is the hard part of this whole process is that anyone can do AI. I mean, anyone can go and download and use TensorFlow. Anyone can write their Python code to do whatever. So this is not true for other things that we have invented in the past. The nuclear power people needed like this plant. You know exactly where this thing is happening. The bioengineering people need like their labs and they know exactly where these things happen. So it was easier to control. It was easier to come up with rules. I mean, for whatever other things we have invented in the history of our lives this past century, we kind of like from a physical point of view could define what that was. Now, like Cynthia was saying before, I mean, this misinformation, anyone can do whatever they want. Anyone can go to a computer and use the internet. So it's a different thing we need to understand how to control. The only thing is like this. I am very optimistic about everything. It's like this. I don't think that we know the answers. What's beautiful about these panels is raising all these issues. But what we have to understand is that there is no one that really knows how to answer all of this. And we need to be part of this machinery that will eventually create something better with AI being part of everybody's lives. So when the regulators come to us and ask this and that, I mean, they have not bad intention. They are just trying to learn what to do. How do we control this process that it's completely distributed, a process that, what else do we have of this nature? I mean, what else do we have with this power? I mean, really not much. So we are in this learning curve. And what we need to do as scientists, as academics, as industry, is to do our best to think about these problems in depth, not pointing fingers at each other, because we really don't know what these regulators need. They don't know. They are trying. So this is a challenge to humanity to work together on a problem. This is a challenge for us. because it's the first kind of invention that requires social people, politics, government, scientists, industry to really think about these one way or another together. And it's not going to be solved by the politicians, by the social scientists, by the AI developers, by the mathematicians. It's just not. So as opposed to many other things we've done in the past. So that's what it's a call for humanity. You guys invented this computer stuff. You invented this AI stuff. Okay, now manage it. You know, it's just us again. It's us humans that have to figure this all out. And I do think that that's the beauty of AI, is that it involves everyone. So everybody needs to be heard, diversity, age, location, you name it. It just cannot be solved like that. So one day we'll have the United Nations for AI, not for poverty or not for energy, but for AI. I do.
I mean, that's certainly one.
Yeah, it's a little bit philosophical, but I do think that it requires us to acknowledge that it's nobody else's only business. It's we are all part of this together. So that changed my attitude when I talk with regulators in the financial world, when I talk with lawyers in the financial world, when I talk with customers and users. So it just opened my mind. My God, we are in all of these together. This is not just me saying we have to do this type of like search algorithm and using these heuristics and this learning. No. This is like a much bigger picture.
I think a lot of people here really agree with you, actually, Manuela. I think one thing that makes this so challenging, perhaps, is that it's not always immediately obvious what the challenges are. Sometimes the challenges present themselves a little bit later. And Alexander, there's a question that I wanted to come to, one of the first questions that came in from Chris Anley, which I think really speaks to this, and also perhaps brings in a lot of what Isaac was saying earlier about how in healthcare, about ownership of data in healthcare. Chris Anley asks whether actually we believe that deep learning on sensitive data, like healthcare data, was insecure by design. I guess really we're talking here about the idea of adversarial perturbations and privacy attacks and being able to infer the original training data from the delicate weights of a model. What's your take on that, Alexander? Do you think that these things are insecure by design?
Yeah, so happy to do that. Just let me quickly, abuse my opportunity and get back to Manuela. And yeah, I totally agree with Manuela that like this is important. We all need to come together. And again, Cynthia, I know this sounds like a cop-out, and it is, but like I really, I wish there was a solution. I can say this is the way to go. Now let's make the politicians do it. I don't know, but kind of, I just learned always, like in some ways. Just one thing I wanted to mention to what Manuela said. She said, "Oh, computer scientists build it. Now they should fix it." Well, I think part of the problem, especially in social media, is that we realize that when computer scientists think about the problem, they might be missing important perspectives. And that's actually what got us in trouble with misinformation and other things. So I wouldn't say that this is, again, something that computer scientists just should not fix it. They should be part of the solution. But I think the important part is exactly to involve other points of view. Anyway, this is all about that. Now, to answer the question, this is the excellent question. And that's actually a question that was driving my research for the last 2 years. I think I'm finally getting to an answer. And the answer is essentially that, yeah, it's not that these things are like insecure by design. I think the problem is that, it's not really about technology. It's about what we think about technology and how we want to use it. Essentially, there is a certain misalignment between, what this technology does versus what we envision it doing. Right. And it's particularly tricky with AI because normally when you have to write a program, you have a specification saying, what does this program has to do? And by the way, like given the way we build the program, it has to be very precise and then it can be checked. And then there's no nasty surprises if this program kind of does something versus does something unexpected. Of course, there is a question of verification. It's difficult, but we know what's happening here. With AI, think about even how do we pose the question? We say, oh, I want this, this model to recognize, on this X-rays if you have tuberculosis, period. That's the whole specification of the problem. Or I want it to recognize birds. And, this is very tempting. That's what makes AI so kind of enthralling and so attractive. But like, it's such an underspecified problem that like, in some ways, you can't really blame that the solution kind of is not what you might think. Because by the way, like much of my work is exactly about trying to find the underpinnings of like where are these adversarial perturbations coming from, what they correspond to. And the answer is that it's really come from the fact that, essentially, I think the best way to just use an analogy, the best way to think about AI is about smart but lazy student. Essentially, the student kind of thinks about the upcoming exam. And he or she do not really want to study and learn the material. All they want to do, they want to just pass this exam with an A. So what do? They study all the prior year's exam. They look what kind of questions you are being asked. They look for patterns. Maybe the teacher always likes to make often the answer A to be the correct one, or maybe the long answers are usually the correct ones, or maybe they like to ask about this material but not this material. Essentially, like they kind of tune to the test, not to the actual underlying content. So when you train a model to recognize birds on ImageNet, well, it doesn't really know what a bird is. It just recognizes what kind of patterns, reacting to what kind of patterns in a correlation-based way, you pass the, you do well on the training set, and this generalizes to test set. And what happens there is that you think, oh, I train a model that knows how to recognize birds, right? But what you discover is saying, oh, actually, if I perturb this image in this tiny way, to me, this is still very much a bird, but my model thinks something completely different. And what you really did is just you essentially find this misalignment between how model recognizes the bird, which is by maybe looking at some combination of some pixels in the picture, and you completely change the what the meaning of a bird to it in this picture, while this was misaligned with what you view as a bird. And kind of, so again, can you blame the technology for that? I don't think that's fair. I think what is the problem is in between, is saying what you expect the technology to do versus what it actually did. So again, this might not be a the answer we want. You would like to have just a hammer that always intuits what we want and just gets there, but we are not there. And I think all the problems with security and safety currently are exactly from us not fully recognizing and grasping with that kind of misalignment.
There seems to be a great shortage of hammers across the board here, really. Okay, we are pretty close to being out of time, but I just wanted to point out that there's some really excellent comments that have come in about people making suggestions of positive things that might be that might work. Two of them were anonymous. One of them was from Dominic Connor, who said that there was some suggestion that perhaps actually some kind of some senior academics in the field of security wanted to do background checks on students before they were shown the way of the dark arts. I'm going to come round to all of you in a moment for your comments on these and maybe additional suggestions, or perhaps even just universities requiring students to pass some kind of ethics tests before they're taught these techniques. There's also two other suggestions about maybe making fake generation of content illegal. Although and how reasonable or feasible that might be, and also another point there, particularly around the idea of social media, that these things are designed very deliberately to be as addictive as possible, and whether we could focus on the addictive nature of this in the same way as one would have done with tobacco. So what I'm going to do, I'm going to just go around all of you. I'll start with you, Cynthia. If you could just give us your thoughts on those suggestions, maybe also throw in another positive suggestion if you could, and then I guess I want you to imagine that you are a sort of suddenly a genie has appeared and you suddenly have access to an incredible amount of funding. Where would you focus that funding in order to make a positive change? I'll go around all of you, but starting with you, Cynthia.
Okay, well, the last question, I don't know how to answer that, but let me
that's fine. Yeah, it's a buffet cast of questions for you.
Okay, so let's talk about incentives. Okay, so what are people's actual incentives? Even people who are very ethically, they think very ethically, they care a lot about ethics. So first of all, it's to not share data. So for instance, with healthcare data, going back to Zach's point that, if you read a paper, and I did this, actually, I emailed the first author of the paper, say, can I please have access to data from your paper, right? Even if it was anonymized data, you don't even have the location, they will just say, oh, I never had access to that data. Or they'll say, well, I destroyed it 5 years ago as I was supposed to. And it's like, but that study was funded by NIH, right? I should be able to replicate it. And it's, essentially, you just can't get access to the data, even if there's no reason to keep it that private, because it's de-anonymized anyway, and you can't, there's no way you could put it together. So first of all, that's our first incentive, not to share data. Second incentive is to ignore ethics in favor of our pocketbooks. So, you know, I can't figure out why it is that, you know, you got companies that are truly evil companies that have done truly evil things. And I'm writing recommendation letters for students for jobs for these companies, and the students are excited about going to these companies. And I just think, what is going on here? Like, if I could have imagined 10 years ago that I'd be writing students recommendation letters to go to companies that have been accused of propagating genocide, there is something seriously wrong in the world. So we have got to think carefully about where our people are going and what they're doing at these companies. I mean, obviously not everybody at these companies is like that, but the truth is that the vast majority of them are, because they're incentivized to do so. If their reputations weren't burnished by being in these companies, if their salaries weren't higher by being at these companies, then, you know, they might be not so proud of the products that they're creating for these companies. And we need to think about that. Like, you're working on the back end. They're like, oh, it's not me. I'm just working on the back end. But that back end is what's making that misinformation propagate faster. And they're not doing anything active to stop that problem. These people are being paid, you know, 5-10 times more than I'm being paid. And I know that. But there's a reason that, you know, I feel like, yeah, at least I'm going to be like on the right side of history on this particular point. You also are incentivized not to criticize companies for having black box models. I do that all the time. I name specific companies and I say, this company is a black box model. And every time I do that, that company goes after the publisher of my paper and says, you know, if there is a publisher, and says, you know, this person has written something false about me. And the truth is, I haven't. I've always cited everything really carefully, so I don't have that. But, you know, I see the emails that are going on. So the truth is that we are incentivized not to do the right thing and heavily incentivized not to do it. And we need to change those incentives.
That's a really interesting point there. I wonder also about the, I guess, the limits of public outrage about some of the more scandalous things, and whether actually, if you had, maybe we just need a little bit more shame, perhaps, like in all of this, to be feeding into that. Manuela, do you want to go next? I think you're on mute, actually, Manuela.
Sorry, I forget again, like, what was your initial question?
Oh, God, there were about 15 of them. So I guess it's like thoughts on these little interventions, whether you have any other positive suggestions or where you would focus future to really make a difference.
Okay, so yeah, thank you. So I have to say that there is a big thing about trying to bring AI to real business, and think about these financial business which existed for centuries was not born digital and relying so much on operation of humans, and now magically these computers can do stuff. And the same thing with health, the same thing with construction, the same thing with government. My heart is now a lot on these non-digital born things in the world. So the Googles, the Amazons, the Twitters, the actual Waze, OpenTable, Ubers, everything was born digital. So the approach was from day one to do it in a way that computers were part of the solution. But there is a lot of things in the world for which the whole business was thought for being carried by humans and not really by machines. So I think that one way or another, I have those companies in my heart very big, in the sense that it would be great if our graduates, the people that grow an understanding of the engineering, of the science, of computers and of AI and of machine learning, would eventually contribute for society all the way from all the ESG values, the climates, the energy, the problems that are crucial in our world, and also art, and also like creativity. So after all, we are not all like buying machines on Amazon. So it's there is more to life, and we care about the health of our dear ones and everything that Isaac was mentioning that is a big problem. So I'm just telling like this. I do think that, how can I say, my opinions are not as strong as they used to be in terms of like, oh, come on, I do this, I do that. I became more understanding that what we need to do is to reach out to the world and try to bring the AI thinking to the world. So the other day here at JP Morgan, I just want to mention one thing, talking with a group of people who's very senior and very, I mean, phenomenal experience on economic decisions, on like, I mean, people that have a tremendous experience. There was someone who was actually sharing that they still don't understand what can AI do. What is this AI all about? What can it do? So there was this issue about, I know a freezer can freeze the food. I know a toaster can toast my toaster. I know a vacuum cleaner can clean a room. So you kind of, I know a car can take me from A to B. So there is somehow a lack of understanding from the general world about what is this AI thing? What can it do? And I think that we honestly should be in the business of reporting. AI can actually process text. AI can do these things. AI can process images. AI can do this. And also, one final thought here is the following, and also be humble about saying what AI cannot do yet, or what are the AI limitations? And there are so many, not creating this atmosphere of the magic of AI being able to do it all. And so that's like also another of the trade-offs. I would be great for us to just say, this is it. Oh, this problem, oh, we can do it. We can track, we can display, we can give you data, statistics about what happened, whatever. So it's a lot of like understanding scoping of a problem, understanding how to address it. I just want to say one thing to this image, kind of like research and to machine learning research. I recently was in a hackathon and I was a judge in a hackathon, and simple hackathon of prediction, some action. And I just want to mention one thing. These people that presented at the end, out of the 100 and some people who participated, like the 5 selected ones, they had only 10 minutes to make the presentation, or 15, and literally 80% of the presentation was on feature engineering. Literally, how did they go from the raw data they received to actually, I'm telling you, they organized by day, they put by month, they did, I mean, you cannot imagine the hacks and the, how do you say, the experimentation that went there. But then what were the curves of the results? Was like logistic regression versus neural nets versus XGBoost results, this classification. And this thing about the feature engineering was not even part of any part of the document. They just stated like this, let these be the features, blah, you know. And so what I'm telling you is like this, machine learning, you know, yes, we have to explain what are the important features that were used. What about explaining the features themselves that were used? So I do think that we have to honestly understand that there is a lot to our science of machine learning, and it's not just this final outcome. And this is where a lot of the knowledge of humans can go into these features. Who knows? But I tell you something. I mean, maybe this is my last statement, but I tell you one thing. We need to grow our hearts to understand that AI is not only this numerical computation of how do I change the weights on a neural net. It is not. AI is about being intelligent and smart, understanding the knowledge, understanding the data, put all this information there, representing knowledge graphs, less knowledge graph, I don't know, standardization versus non-standardization. I mean, I was amazed about this feature engineering. And, you know, half of them got it right and the other half didn't. And they did not come up with the idea of the other half. And there was one that was all hierarchical kind of features, and that was the best performance. But nothing of that came from an algorithm. It came from this tremendous knowledge or a tremendous insight and tremendous scientific and engineering developed of that person. So machine learning has that black art that we have to embrace as part of the AI science. And AI includes the machine learning, but it includes the knowledge, includes the feedback, includes all sorts of like perception, images, pixels. How many pixels do you use? I mean, the whole thing is like complicated. So I'm just saying that it's a beautiful field, but it's something that we have to honestly know what we can contribute for a particular business. How far can we go? And the example that Isaac was saying about sharing the data for patients who actually know is something we can do. It's something we can do. It's not really magic or something. No. It's a first step. They are in control. They can check. They can see. They can manipulate. That's fine. We can make information available. We can organize information. So if we demystify this, it can do it all, we probably will advance more. I just go 5 seconds to say one thing. No matter what we think about AI and something, I do believe that there are many opportunities for AI to improve what we are doing, like Isaac said. So whether it's the autonomous cars or whether it's whatever it is, I think autonomous cars is fine. There is too many people thinking about it. Let's put more millions, more billions on other things than autonomous cars. The autonomous cars are checkmarked. Yes, we have all the great minds working on these. We are fine. But we need also great minds working on knowledge, health knowledge sharing, standardizing, using all these. We need more great minds on other areas, not just on these autonomous cars. So I do think that that's where these monopolies should be broken, is in making like spreading these opportunities throughout all those branches of society and not just these autonomous cars.
I think I really like the idea of a bit more of a focus on the intelligence side of AI and actually making it more intelligent. Isaac, just coming to you for your final thoughts on everything that's been said.
Well, first of all, I love Manuela's framing, and she's absolutely right. There is that. I actually want to just say that those of us who've been in machine learning and artificial intelligence for 30, 40 years understand actually how profound her comment actually about feature engineering is. We've always imagined that somehow these computer programs would figure out the right derived features in order to get to performance. But again and again, we find that having ingenious, knowledgeable feature engineering turns out to be very important. But I want to answer your question, the last question that Cynthia said she didn't want to answer. I'm going to answer it to you. If I had billions of dollars, and I suppose I should do the
You
Dr.
had.
Evil.
Yeah, he has billions of dollars.
Oh, okay.
If I had, if I'm saying, I'll give it the Dr. Evil look. Yeah, if I had those billions, I think that we could do two things well. One is increase opportunity, and the other is to address some of the things that Alexander talked about, change incentives. So I'm mindful of the fact that a mathematics professor at MIT, Jim Simons, who went on to become a billionaire through hedge funds, and because of his concerns around autism, transformed autism research by creating incentives around data sharing in that community so that you would not get funded if you not, I promised, but you didn't actually share data and did not actually collaborate. And again, I said this at the beginning, I do not think it is an overstatement. It's hard to overstate the impact of the UK Biobank in establishing the ability to do a variety of different correlations across genomics and clinical care. And it's created so many business plans, so many opportunities for research. And so I'm frankly a little bit skeptical about our ability to create different paths of regulated behavior because there's always going to be other incentives. So I think creating the incentives that we want to promote and the data sharing and putting money behind the data sharing policies is probably the place that we can have the most impact.
And finally, Alexander, coming to you, you've certainly got billions of pounds. What do you want to do with it?
Well, that's a little bit of a responsibility, but let me try to see. So, by the way, just since this is like the final thoughts, and I feel that I just want to make sure we have the right vibe for the people attending it. I just want to give a little bit of, I guess Isaac was also, actually we are kind of optimistic, I guess, in the end. But like, I must say that, even though I usually worry about the use of AI, I think we are making progress as a kind of, as a society. Like, I think we are getting more mature in understanding what AI is, what it can solve, what it cannot solve, and what it should not be using to solve. And I think that's a very sometimes hard-earned knowledge, but we are getting there. So yes, so AI will not solve healthcare. that can have impact there. If applied correctly, it will not solve finance, but can have, you know, important contributions. And I think this will be the art, and that's where we are going, of understanding what we should, like, where is the boundary of what we should, you know, before we do any technology, what is the boundary that you should be even attacking versus leaving it aside. So I want to, you know, I want to kind of do a shout out to that. I think this is happening, and I'm, you know, people on this panel, including, you know, I think did a lot to kind of to have this kind of more healthy relationship with AI. Let's just say, like, you know, fostering it. Also, I want to say, just to shout out to Manuela for the kind of the, I think AI, yeah, we all think about self-driving cars. We all think about, like, there's just so much more that AI could be used for. So here at MIT, I'm hearing from my colleagues in chemistry, in, you know, biology, in material engineering, that this is transforming, like, this kind of essentially the pattern search that AI is able to do is transforming the kind of design of drugs, finding new compounds and so on. And this is like something that I think we as a core machine learning community are not really internalizing yet and fully engaging. So I think getting there early, so we make sure that these tools are applied the right way, will be very important. But again, in the overall, this is super exciting. And just, you know, now what is a little bit less optimistic, but actually not too bad, is also the regulation aspect, which, you know, which Cynthia and Isaac and Manuela, everyone talked about this. You know, again, I think this is not something you can delegate to regulators, regulate this AI for us. But the one thing I do recognize is they are, like, we should engage, but the good thing is they want to engage as well. Like, they definitely, like, you know, my interactions with them, you know, with Fed, with other, like, they realize that they need more domain knowledge, that they might not have it inside. They know, they understand finance, for instance, but they don't understand, you know, AI. So they are willing to work with us. And, you know, and I guess, you know, I think all of us kind of are involved in different kind of engagement, and, you know, that's a good thing to do. But, like, the more I actually spend quite a lot of time thinking about this and talking to people, and it's really a difficult problem. I'm learning a lot, but I'm humbled by kind of how difficult these things are. So that's why I'm not jumping to giving solutions. But anyway, now in terms of what I would do with £1 billion, so it's an interesting question, right? So, you know, I would say that it definitely, like, academia is underfunded. Again, being an academic, I will always be saying that, because I think this is always true, by the way, because especially compared to the value that this creates long term. But I don't think this is only about throwing more money on R&D. And by the way, if you follow the legislation, there's a lot of money that will be essentially pumped into the also basic research system around AI. But, like, what I think we should reckon with is that, you know, it's not only about funding, it's also about incentives. And I think the way the current machine learning community works is just not the right way. Like, to be honest, you know, just, it pains me to say it, but, like, to me, I find it very difficult to navigate even the literature in the field. Like, it almost came to the level of noise. Like, everyone publishes, no one has time to read any other papers relating them in any meaningful way. You know, essentially the conferences became almost like a lottery. You know, kind of, you just had 3 reviewers who are overworked, not really knowledgeable, and they just give some recommendation. And there's an overworked like area chair that kind of looks at it and just writes something based on this. Like, this is not a scientific process. And I think the sooner we recognize and acknowledge this, I think this would be healthier for everyone. And, you know, so if I had to kind of power to funnel money into like basic research in academia, I would actually, like, make it, you know, essentially, like, well, I would first of all encourage this kind of thinking about the community, how to change this, you know, this incentives of the publishing system, I would say, and current publishing system and its scalability. So I would say, you know, it's, I guess, very fashionable right now, invest in infrastructure. And it comes in many ways. Like, first of all, you need to solve the scalability problem of peer review. Maybe you should give up on peer review, or you should have some other questions. But there's also investment in data sets, like well-annotated data sets. It pains me that much of my research is done on 3 data sets. Actually, 1, ImageNet. That's not, you know, that's really this is not really science, you know, to be honest. It's not science. This is not how it works. And, you know, and what pains me is I know my colleagues at Google have tons of vision data sets that they can, you know, do whatever they want with, but there is no way for me to do it. Like, academia is not really, you know, they say, oh, academics should care more about creating data. We are really not, like, this is not what academia is about. This is, like, requires engineering, investments, and so on. So yeah, if I had money, I would kind of have some kind of infrastructure funding into public data sets that can really inform the research. And also, you know, availability of compute so people can do large scale experiments, and also kind of fostering a culture of proper evaluation. But again, this requires non-trivial engineering skills. So kind of the question is like, like my students, as amazing as they are, they're not engineers. Yes, like they have, so many ideas to kind of to figure out. Spending time on actually properly, like they still do this. It takes a lot of time, but I'm not sure this is the right setup of like, cleaning up the code, making it actually robust. It's maybe not production ready, but it's definitely like robust enough for people to adopt. Like none of this is happening because we just don't have time and we don't have resources for that, and that needs to change. And I guess, and this, by the way, goes back to what Cynthia said, because I want to shout out to her, is that like I think the relationship of industry and academia in ML is just wrong. Like again, she already touched on some of this. I would also say the other thing is that I think industry kind of treats academia as this kind of forest, where whenever you need something, you just go chop the tree and you just like ship it out. So yes, they are happy to hire us as consultants. They are happy to take our students, but they are not thinking about about this data. Okay, like we need to make sure that this academic system is nurtured and well maintained. It's just kind of we are just taking, and there will be always more. And and there's more I have to say here, but maybe I think this panel is controversial enough. And so just the final thought, and this is also like to kind of shout out to Cynthia to some extent, is that one thing that I realized over the last 2 years is that being at MIT, which is one of the top technical institutions in the world, is and I love it. Don't get me wrong about that, but I realized that like there is something a little bit wrong about how we teach our students. And what I mean by that is that MIT has this, and not only MIT, but I'm just here at MIT. It's just like we have this ethos of like, if there is a cool technology to be built, just build it. There's like technology is inherently good. Just build stuff, and then you disrupt the world, and things will be happening. That's what you are. That's your mandate to do. And I really think that this is the wrong message to say. I think we should already with great power comes great responsibility. And I think we need to really take it seriously, also educators, and kind of send this message already when we are teaching the students. So for instance, with my colleagues, I'm developing a class which tries to make these points about if you use data-driven approaches in decision making, it has consequences. Decision making is kind of difficult, but again, this should be something more broadly. I think we really owe it to our students to teach them how to be more thoughtful about technology as they develop it. And we also I think owe it to the society. Again, I think we need to engage in this with politicians, regulators, industry, nonprofits. But again, just there is something about we had great success with AI as a technology to be adopted, but now I think it behoves on us just to make sure the way it is adopted and the way it's deployed, there is the right culture of doing that. Yeah, so thank you for the panel.
That's a very, very good point to end on. I think what we owe to our students and also what we owe to society. Thank you very much to all of you for joining me. That has been a real delight. There are lots of really interesting stuff in the chat too. Thank you, everybody.